Hello. Someone asked me the question, what is the difference between sine and sine law, and how does this apply to does this have something to do with the Pythagoras theorem? So I'm going to go through a quick example and talk about the difference between sine and sine law. So when we ask about the sine of an angle, what we're interested in is the ratio of what's called the opposite to the hypotenuse. So if we draw a right angle triangle here, so when you start learning trigonometry, you start by learning about three primary trig ratios. And these primary ratios only apply to right triangles. And these three primary trig ratios are sine, cosine, and tangent. And so what we say is we say that the sine of some angle, so sine of, if we say the angle is called theta, is the opposite over the hypotenuse. Let's give a little more space here. Drag these over a bit more. We say the cosine of an angle is the adjacent over the hypotenuse. And the tan of an angle is equal to the opposite over the adjacent. And there's lots of ways to remember these. Different little tricks. Some people remember this thing called Sohcahtoa. So now, remember, primary trig ratios, when we first start developing sine and cosine, apply only to right triangles. So I could give you a triangle like this, and I could say, well, if this is 1 and this is root 3, and this is some angle theta, I could ask you to find theta. Okay, well, if we take a look at this, if this is the angle in question, so there I am, I'm a guy, I'm just kind of standing here. What I need to do is I need to name these sides. So this, if I go straight across from the angle, this is called my opposite side. If I go right next to it, this is my adjacent side, and the other side is the hypotenuse. So what I can do is I can, remember, sine, cos, and tan of an angle is simply a ratio. It's just taking one side of the triangle divided by the other side of the triangle. So in this case, if I want to find theta, I could say sine theta, well, I could use sine, let's see, is going to be the opposite, so the opposite is 1. But notice the problem here is I don't know what the hypotenuse is. So sine's probably not the best choice. Well, what about if I use cosine theta? If I use cosine theta, well, again, cosine theta is defined as adjacent, which is root 3, over the hypotenuse. But again, same problem, I don't have the hypotenuse. So let's try tan theta. So tan theta is defined as opposite over adjacent. So again, if I'm looking at this angle, if this is my perspective, 1 is the opposite, and root 3 is the adjacent. So that means I have enough information to find the theta using tan. So I can say theta is equal to tan inverse, and you'll see a little button on your calculator, which is tan with it looks like the power of negative 1. We don't want to say it that way because it's not tan to the power of negative 1. That's different. Just a little side note here. Tan to the negative 1 would actually look like that. So be aware of the difference. This is said tan inverse. It's the inverse operation. And I get 30 degrees, which is awesome. So now I've solved for theta. But your question was, how does Pythagoras theorem relate? And what happens is Pythagoras theorem can be used to find one of the sides of a right angle triangle. So we know that Pythagoras theorem is the hypotenuse squared is going to equal the opposite squared plus the adjacent squared. So what I can do here is I can say that if I wanted to use sine or cosine, I could actually go through and calculate hypotenuse by saying the opposite is 1 squared plus root 3 squared. And then 1 squared is 1 plus root 3 squared is 3, so that's 4. So the hypotenuse is equal to 2. So therefore, I'm a little all over the place here, I apologize. So therefore, what I could say then is that, let's go right here, sine of theta is equal to the opposite, which is 1 over 2 So theta is equal to sine inverse of 1 over 2. So theta is equal to 30 degrees. And we should get the same answer. So your question is, first thing is, how does this all relate to Pythagoras' theorem? So our primary trig ratios, sine, cos, and tan, are defined as the ratios of the sides of a right angle triangle. And those ratios are dependent on what angle I'm talking about. So if I'm standing here, opposite, adjacent, hypotenuse. If I was standing here, pretend, so up at this part of the triangle, then the opposite and the adjacent switch. So given a right angle triangle, I can choose one of these ratios, if I know the sides, to find the angle. But if I was only given some of the information, I can use Pythagoras' theorem to find that missing piece of information. So sine, when I talk about the sine of an angle, I'm talking about, so sine of an angle is the ratio of opposite over hypotenuse. Now, we haven't gotten to graphing these at all, and there's some pretty neat stuff you can do when you start graphing these. So then the question comes, what about sine law? Well, sometimes we run in this situation where, okay, right angle triangles are great, but life doesn't only consist of right angle triangles. Sometimes we're going to end up with triangles that aren't right. So in this case, I couldn't actually find sine of A, because the problem here is sine of A, well, in this case, this is not a right angle triangle, so I don't have an opposite and hypotenuse to talk about. So what we could do is we could force a right angle triangle if we wanted. So let's do a couple things here. The first thing I'm going to do is going to name this triangle. So if this is vertex A, that's small a. If this is vertex C, that's small c. If this is vertex B, that's small b. And what I'm going to do now is I'm going to force a right angle triangle because our primary trig ratios only work with right angle triangles. So I do that by dropping a perpendicular. And I'm going to call this H. So if I say sine A, the opposite of A would be H, and the hypotenuse then would be C, so I have H over C. Okay, oh, pardon me, I wrote that out wrong. H over C. Okay, well, what else can I say? Well, I can also say that sine C is equal to H over A. Okay, so therefore, by systems, we can use our ideas we've learned in systems of equations, is that A sine C is equal to H. If we call this 1 and we call this 2, this is simply rearranging 2 to get H, multiply both sides by A. So therefore we can sub, let's call this star into 1. So therefore sine A is equal to A sine C over C. So sine, we can do some algebra, sine A over A equals sine C over C. And we now have related the angles in the sides using what's called sine law. Sine law is a law that relates the angles, the sine of the angles and the lengths of the sides of a non-right angle triangle, and it's the ratio of, so sine A over A is the same as sine B over B, which is the same as sine C over C, sometimes written like this, A over sine A, if we can take the reciprocal of every side as well. Oops, I'm making all sorts of little mistakes here this morning. So, just to sum up, what's the difference between sine and sine law? When we talk about the sine of an angle, we're talking about the ratio of the opposite to the hypotenuse. And that ratio can only be taken from a right angle triangle. So our primary trig ratios, and there's 3 of them, apply to right angle triangles. So then what happens are people, well, they want to figure out, they want to solve things that aren't necessarily right angle triangles. So to do that, if we take a triangle, we can actually do a little bit of derivation by taking a triangle, making it right, and we can figure out a relationship between angles and lengths of sides using sine, and this is called sine law. So sine law is a law that is developed using the sine ratio that can be applied to any triangle. I hope that helped.